You can see, even though they're not part of the locus itself, I've put on D and S because they define the locus, right? They're part of the definition. You don't have them, it's kind of like, well, what is this line doing? It's just out in the middle of nowhere doing its thing, okay? But as it is, you can see, there's Richard, and there's me, and there's you guys, right? And you can go ahead and label them if you draw, you know, reasonably. Sorry, okay, I'll put Richard. And you kind of have long sort of hair like that. There you go. Okay. So yeah.
Do you have to do the equidistant thing? Or?
Okay. No, you don't. So I've put on there. I've labelled on the perpendicular angle and you know the interval ds and the bisection. Okay, just to show you. Okay, and you should be able to, even if you don't actually do it, you should be able to do them. If it doesn't look like a right angle, something's gone wrong. Okay, so it should look sort of in the ballpark. Okay. All right, we did a circle, we did a straight line. What was the last one? Okay, now how does this work? Let's do a simple example. I'll just leave that there for a second. No, it's not. I just didn't want to, yeah. No, it's not. I could have gotten a ruler, I was too lazy. I apologize. Okay. A parabola. Now, the one we're about to do, we're just going to do basics of it. The idea of a parabola and its locus is so important. There's a whole topic for it later on. It's called, very imaginatively, locus and parabola. Okay, so it's its own topic. We'll deal with it in a lot of detail. For now, let's just do the basics. Okay? So, this is what example are we up to? Number 3, I think. Okay. So, they all start off the same way, right? A point P moves such that. Now, do you remember what were the geometric instructions I gave you? I said there was a point, right, a person, and there was also a straight line, right, the wall. Okay, so it's equidistant such that it is equidistant from. Let's see here. Okay, again, we'll stick with simple ones. Let's go y equals 1, and let's call this point A. Where should I put it? Is that right? No.
That's the point on the line.
Other way around, sorry. I meant 1, 3. That's better. Okay. For what it's worth, if the point was on the line, it would be a very easy locus. Just be a straight line. But anyway. Okay, so there's our y. Okay, now again, for later, and this is dealt with all under the topic that I said before, but you may have heard the word before, so I might as well mention it. This line is called the directrix. Because what it does is it defines the direction of the parabola. The parabola we're going to do, it faces in a certain direction. You can make the parabola face in any direction you like, based on the equation of this line. Okay? Bless you. The other point, the point is called the focus. Okay, and you'll see why in a second. Okay. All right. So how are we going to set this up? Before we just had nice, easy distance formulas. Okay, and we will have one distance formula because we're going to say the distance from P to A, this point here, right? That should be equal to the distance from P to. Okay. Now, I probably should have given this line a name. So let's name it. Okay. Let's call the line L. For line. Okay. So distance PA should be the same as distance PL. All right. Left-hand side, super easy. What we've been doing before, just a straightforward distance formula. Okay. So I've got the square root. X minus 1 squared. Y minus squared. Okay. But as you can imagine, the right-hand side is a little trickier, right? It's not a distance between 2 points. It's the distance from a point to a line. Okay. So this is the perpendicular distance formula. Perpendicular distance. Now, this falls under the coordinate geometry revision that you meant to do at the beginning of the program. If you're a little shady on it, and you what does it look like? Okay, let's do it together. Let's finish this. What's on the top? It's a fraction. What's on the top?
Absolute value.
It's absolute value. Okay. What's inside here? The easiest way to remember it is it's a bit like general form. You notice here I finished on general form, okay? That's probably the best way to leave it. I did it like this because I had to graph it, okay? But general form is ax plus by plus c, okay? That's general form for a straight line. Perpendicular distance is just a little different. This x and this y, what do they refer to? They refer to this point that I'm measuring from, right? So it's actually x1 and y1, okay? What are the a, b, and c from? They're from the straight line, right? This line, okay? Now, y equals 1 is not in general form, and I need to put it in general form. So I'll just quickly say, well, I guess it's 0 lots of x plus 1 lot of y minus 1. Okay? Do you have to write it like that? No, but I can see what a, b, and c are, just to make it easier for me. Okay? What's on the bottom? Square root. Good. And again, comes from Pythagoras. Okay? Alright, so let's quickly just execute this, and I'll let you finish it off. Do we have a lesson later? Yep. We're going to split double, right? Yeah, okay. So I'm just going to write this out, we'll sub it in, and then you can simplify it out. Okay, so I've got the absolute value on the top. A is 0, lots of x, 1 lot of y, minus 1. Okay. Square root. Okay, there's my setup. We'll finish it this afternoon.